So assertions are an important enough topic that we're going to want to cover them separately. So an assertion is an executable check for a property that must be true of your code. So for the square root example that we've been using, we're defining a function called square root, which takes an argument. We're going to use that argument to compute a result, and here we're going to assert that the result is greater than or equal to 0. So let's return to the square root example we've been using. So here we're going to define a Python function called square root, which takes an argument. There's going to be some code at the top which computes the result. And now what we're going to assume is that if the argument to the square root was negative, this bailed out with some sort of exception. So if we reach this line in the code, then we've successfully computed a square root result. And what we're going to do is assert that that result is greater than or equal to 0, and then return it. And so why did we assert that the square root result is greater than or equal to 0? Because we know that by definition, our square root function is returning the positive square root of its argument. And so at this point in the code, we know that we must have computed a positive number. So it's good to go ahead and assert that. So let's look at some basic guidelines for putting assertions into code. The first rule is that assertions are not for error handling. So for example, it would have been a mistake at the beginning of this routine, probably, to assert that arg was greater than or equal to 0. That would reflect a condition that we want to handle with an exception, that is to say, with Python's established error handling mechanism, and not with an assertion. The assertion that we put into the code asserts the result of our logic that we wrote is sane. It's not asserting something about the behavior of some other entity in the program. That would generally be more in the domain of error checking. Rule 2, and this is really important, is never make assertion calls that have side effects. An example of a side effecting assertion would be asserting that a function foo returns the value 0, but where foo changes the value of a global variable. And the problem with side effects and assertions are, when we turn on optimization in Python, it's going to drop all of the assertions in our program. So what we're going to have is a program which happens to work correctly because the assertion changes a value in some way that's needed. But on the other hand, when we turn on optimizations and drop all of the asserts, then the program's going to stop working. And this makes the assertions worse than useless. This is almost the worst possible thing you can do with an assertion, is have an assertion in your code that changes the global state in some observable fashion. So we definitely don't want to do this. Now rule 3 is we don't want to put silly assertions into our code. And let me give an example. So here we're asserting that 1 plus 1 equals 2. Now is it conceivable that in some Python program 1 plus 1 was not equal to 2? Sure, it's conceivable if the Python interpreter is incredibly broken. But on the other hand, if the Python interpreter is that broken, nothing is going to work. Our program isn't going to run at all. So in any case, there's no point whatsoever in doing a silly assertion like this. The best assertions are those which check a non-trivial property that could be wrong, but only if we actually made a mistake in our logic. So it's not something that could be wrong if the user did something wrong, and it's not something that's wrong that's just completely silly to check. So now I'm going to let you guys write some assertions.